average rate of change and increasing, decreasing, those are the two things we're going to talk about today. And then we had 1.3a. This is 1.3b, yeah. We're skipping all around. It's so much fun. All right. So the first thing we're going to talk today about is average rate of change. It's very easy. It's a formula. But what you need to be familiar with is this phrase, average rate of change. Sometimes they'll just have rate of change. Sometimes they'll say average speed, because I don't know if you know this, but your speed and rate are did you ever hear of distance equals rate times time? And distance equals speed times time. It's the same thing. So rate and speed are interchangeable. So average rate of change is very easy. It is your change. In mathematics, change means subtraction. So it's your change in output over your change in input. Your change in output over your change in your input. Oh, well, let's be real. There's got to be an easier way than that. Yeah, you've been doing this, honestly, since 8th grade. This is slope. That's all it is. Now, when I asked the other classes, what is slope, they told me y equals mx plus b. That's slope-intercept form. How do you find slope? Which is what? What's the formula, though? y2 minus y1. Okay, so if you don't know that, let me tell you what's going to happen on the next quiz, which will be next Tuesday. The biggest problem I get from pre-calculus students is they flip-flop these. They put the x's on top and the y's on the bottom. Again, you've got to be better than that, guys. You can't make these mistakes anymore. You're in pre-calculus. Could you imagine if the engineers out there at NC State couldn't get the y's on top and put the x's on top instead? What would happen to our things that they're building? I don't know. Do you not, and you're like, well, Miss Edda, can't we just have partial credit because I put the x's on top? No! No! You have to be accurate. There's no more, can't you just give me partial? No! Be accurate. Slope. All right, so let's do 3 quick examples. They're very easy. Find the average rate of change. I don't feel like spelling it out. AROC. We'll just call it AROC. Of g of t equals t squared plus 3t plus 1 on 1 comma 4 with brackets. And I'll explain what that means. Find the average rate of change of g of t equals t squared plus 3t plus 1. Okay, now, let me explain something real quick that's going on here. This is interval notation, right? Isn't that what brackets mean? And it's an interval notation on the x-axis. So both of these are x's. So this is an interval on the x-axis. And so you need to, what I would do for this problem, this is how I always start this off, I actually make a table because I think it's easier to look at a table. And I put my x's on the x side, so I go 1 and 4. So whatever they give me here, I put it right here. And then I find my y's. Well, this is not hard. This is not complicated. How do you find a y if x is 1? What would you do? Plug it in, right? Well, let's pretend, not this class, people don't know how to plug in stuff and get it right, like 3 squared is 6. Put it in the calculator. So everybody go to y1 and type in x squared plus 3x plus 1. Like, the calculator will do it for you. I don't know if you know this. We did tables last week, and we can make a table. Now, here's the only thing you have to be careful of, and you have to learn this because you have to learn your calculator, okay? Your problem is if you go to table right now, it's set at 0.01. So you need to change it back. Go to table set and always just go 1, 1. 1, 1 will always give you an interval of 1. And then you can go to the table. And look at that. If you plug in 1, what do you get out? 5. And if you plugged in a 4, you would get out a what? 29. And now, remember, we haven't done this yet. We're going to do slope. Easy. y2 minus y1, x2 minus x1. So 29 minus 5 over 4 minus 1. And that's 24 over 3, which is 8. That's the average rate of change. It's about 8. Easy peasy. Will it always be that easy? Of course. Let's do another one, because they might switch it up on you. All right, given a table, find Anna's speed. I chose Anna because I love her. Find Anna's, average speed. That's that word, average speed on the interval 2, 5. So this next question, they're actually going to give you a table, and it's going to go this way. T stands for hours, and D of T is your miles. So at 0, she was at 10 miles. At 1, she was at 55 miles. Whoa. 2, 90. 3, 153 miles. And then 5, 240. So now they're giving you a table. If you don't understand the table this way, on top is always your x's. On the bottom is always your y. So table left is your x, right is your y, but if it's this way, x is your top, okay? Now, again, here's the interval they gave you, 2, 5. You only need to worry about, are you with me? The 2 and its y, and the 5 and its y. And you find the average, the slope, at those 2 points. Now be careful. What's your y's? What do you do? What minus what? 240 minus 90. Again, I have people going like, I did 2 minus 5 and I got -3 on top. No. You put the y's on top. 240 minus 90. And what should I go over? 5 minus 2. What does that reduce down to? 150 divided by 3, which is 50 miles per hour. That's her average speed. Very easy. So this is how you read it from a table. Read it from an equation. Read it from a table. Same thing. One more. They give you this one. Find the AROC, average rate of change, given f of x equals 2x squared on the interval 3, 3 plus h. Ooh. Uh-oh. Am I going to have to FOIL? Probably. Okay. Don't freak out, but they're not numbers, there's letters. It's okay. It's literally the same as up here. You just are going to have to do some algebra. I gave you an equation, gave you an equation. I gave you an interval, I gave you an interval. Okay? I'm going to do the same thing I did up here. Watch. I'm literally going to make a table. And I'm going to put my x's. This is the x interval. I'm going to put them here, 3, and then one of them I'm going to put 3 plus h. I do the same thing. That's why I like math. If you just follow the way it's supposed to do from another problem, it helps you with the next one. It's really not that bad. Now, this one, unfortunately, you can't put it in the calculator. Well, you could 3, but most of you could do 3 right now. What's 2 times 3 squared? Put 3 in for x. What's 2 times 3 squared? Anybody? 18 is right, not 36. Who does that? Who puts 2 times 3 first? I mean, order of operations, obviously. 18. Okay? What am I going to do with this one now? What am I going to do? Plug it in. 2 times 3 plus h squared. Now, nobody in this class would call this 9 plus h squared. No. What would we do here? There are people learning, and their names rhymes with Marley. 3 plus h times another 3 plus h is a FOIL problem. And you should FOIL fast. 3 times 3 is 9. 3h and 3h makes 6h. h squared is the last. And then you multiply the 2.
There we go.
She had a brain fart for a minute. She was like, what? I do. 18 plus 12h plus 2h squared. Okay, now here's the problem. We haven't even done slope yet. We got to do slope. And slope says y2, right? That was your y, minus y1 over x2 minus x1. Okay, go ahead, write that out for me and see if you can simplify it. y2 minus y1 over x2 minus x1. Do you have something that looks like that? Can I clean that up? What can go away on the top? Couldn't 18 and a minus 18 go away? Couldn't a 3 and a minus 3 on the bottom go away? All right, so now I have 12h plus 2h squared over h. Well, if they all have h's, couldn't I reduce? What does it reduce to? 12 plus, my friends, that is the slope. Listen to me. I'm going to give you a big hint. Next year, when you take calculus with me, we do calculus 1. The first 4 chapters is something called a derivative. And all a derivative is the slope. And you just did that. That's all it is for 4 long chapters. Derivative. Slope. Queen. All right, so average rate of change. It's slope. Oh my gosh, so easy. Flip it over. We now got to do increasing and decreasing, and we donezy. Could you please, no, not that one, because, no, that one. I hate when I lose all my papers. Oh my gosh, the complaining already. There's no complaining. We don't complain. Oh my gosh. All right, second thing we're going to talk today about is increasing, decreasing, and something also known as extrema, okay? So if you could sketch this real quick for me, and then I'll explain how to find where the function is increasing or decreasing, and then find something called extrema. It's very simple. Everybody else seemed to like it in the other class. Hopefully. You want me to zoom in? Sure, probably. There you go. You don't have to be super, super accurate. I mean, you could just kind of sketch it, and we'll label it. Like I said, just sketch it.
We don't have to write.
It's okay. Sketch it.
I think we did. Yeah, I think some of this we like guys stop saying. No, not your mistake.
All right, here we go. Number 1, when we're going to do increasing and decreasing, you are going to use interval notation. However, you never use brackets. No brackets, ever. But Ms. Seta, it lands on it. I know, but this is a nice thing for you. So if you were kind of confused on the quiz and you forgot a bracket, you just always use parentheses, always. Only for increasing and decreasing. Let me say this again, only for increasing and decreasing. If you miss a bracket on domain, you're wrong. But if you miss a bracket here, you're right. So just so you know, always just use parentheses. Yay, not hard. Number 2, this is the most important part that students get wrong. You're increasing and decreasing along your x. I don't know, did I give you food? I gave you food? No, I didn't give you food today. I didn't buy you a meatball sandwich. Whoopsie. Okay, have fun. Along the x. Judah problems. Along the x-axis, the domain. You always do it along the x-axis. You always give me x's. Don't give me y's for interval increasing and decreasing. Give me x's, okay? And the third thing is you read this graph like you read a book. You read a book on the left and then go to the right. So always start left and then go to the right. And now let me show you how to do these problems. It's really not that hard. Watch my pen. Ready? What is my pen doing? So it would be So you're going to go like this. You're going to write increasing. Now, on the left side of the x-axis, even if it goes to arrow, that means I must be starting at a very left number on the x-axis. What is a very left number on the x-axis? You always start at negative infinity. Always, always, always. Always, I won't give you a problem where you won't. And then guess where you're always going to end? Oh, you're always going to start at negative infinity, okay? Now, so I am increasing from negative infinity, watch my pen, until about here. Would you agree? But where is that on the x-axis? Negative 3. Okay, and then once I get to here, what happens to my pen? I decrease. Now watch. Wherever you left off, write it again. Wherever you left off, write it again. Negative 3 until about here. Would you agree? What is the x point there? Positive 2. All right, and then what happens to my pen after that? So you go back here. You don't have to put a U. You just put a parenthesis again. Wherever you left off, put it there. And then if I'm going to keep going up, where am I going to go on the right side? Look at you. You just did the problem. Now, these 2 points are known as extrema. In mathematics, extrema is your maxes and your mins. Have you heard of those words before? Okay. Well, we now give them even more special names. We call them local max or local min, or absolute max and absolute min. And we're going to figure out what these are real quick. So point A, I'm going to tell you right now, is a local max. Yep, sorry, thank you. Point A is a local max, and here's why. It is a high point, but it's not the highest. It's a high point in the graph, but why is it not the highest? Well, because doesn't this line keep going on forever and ever? And there's always going to be a higher point than that point? But it is a high point. It's a bump in the graph. It's a max right there, okay? Now, here's the problem that you have to say, because this is what it's going to ask us. What is the local max? Well, here's what's weird. This is x's. Your local max is your y's, your y value. And so you would say, I have a local max of, what is that y value? 4. I have a local max of 4. Look, watch. When x equals negative 3. That's what you have to say. Again, I have to teach you all this phraseology because that's what they use. I have a local max of 4 when x equals negative 3, etc. Okay, cool. Then what do you think B would be?
I think it's opposite.
So a local min. It's a low point, but it's not the lowest. Low point, but not the lowest. Low point, but not the lowest. So again, if you were to answer this for me, you'd say, I have a local min of, what's the y value there? So I have a local min of negative 3 when x is what?
3.
When x is what? 2. And that's how you do those kind of problems. Be easy. Okay? You don't have to, again, you're going to sketch what I give you here. Don't worry about it. We're going to do this example, and then I'm almost done. You're going to tell me where this is increasing, decreasing, and what are points D, E, and F, and then we'll be done. I want you to put this in your notes. Just draw a little W. Draw a little funky little W like that.
Are we doing it together?
We'll do it together, sure. Okay. Starting on the left, even though it's pointing up, what's my pen doing from the left to the right? So I am, and where do I always start? Someone is listening and his name rhymes with Marley. Always start with negative infinity. Remember yesterday when he was wrong on everything he said, or was it that day before? That's okay. Yeah, it's okay.
No, it's big.
It's day before. Negative infinity, listen, to the x. To the x. Where is the x here?
-4.
To the x.
That's so awkward. That would be 2.
Negative.
-2.
Negative 2.
I'm sorry.
We do it on the x. We decrease and increase on the x, 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 okay? You only give me y's if it's max or mins. All right, then what do I do after that? Increase from wherever I left off, -2, to where on the x?
I got it. That would be 1.
What do I do after that? So I go back up here, wherever I left off, put a 1 again. To where on the x?
4. I can't see it.
And then what do I do after that?
Increase.
From?
4 to infinity.
Good. Okay. Now wait. Now you got to tell me what I have here. Point D. What is point D called?
Local.
It's not local min.
Oh, no.
It is the ultimate min, also known as, I wish that was called that, the ultimate min. It is an absolute min. There is nothing else lower. It is an absolute min. And what is that absolute min value?
Negative 4.
-4
At -2.
at x equals -2. We are getting it. Absolute min, I should have said of -4, but that's okay. All right, what about E? Local max. It's a high point, but it's not the highest because this guy goes on forever. And what is that local max value? That y value is 2, and at what x point?
1.
Brilliant. What about F?
Local min.
Local min. Of what? 0. At what x value? That's what homework is like tonight.
Wait. Scroll. Yeah.
Scroll.
Scroll. F is.
We're not done. I know. Ah! It's a technology one. I'm going to show you on night. What?
Can there be several local?
There could be several local mins. Well, let me put, you can have the same local min at different points. Does that make sense? Because your min is the y value. You're always going to have the lowest point is going to be a y value of 2, but you could have one at x equals -2 and one at x equals 5.
But let's say like there's another like wave.
Like if there's a bump at the same.
Yeah, let's say there's a.
Oh, yeah, yes. I'm sorry. I'm thinking absolute. My bad. I totally am thinking absolute. I'm thinking of a W. I thought you meant like a W here where you'd have it. Yes. Good point. All right. I want you, this is some technology. You are going to use Desmos tonight. I want you to write this in your notes. I'm going to put it up here on the board, and then we're going to be done. You are going to graph -2x to the 6th minus 4x to the 5th plus 5x squared minus 4x cubed plus 5. Now, you can graph this, just write it down. You can graph this in your calculator, but I'll be honest with you, you guys get the Desmos on the SAT and the ACT, and it would be much easier for you to learn Desmos. If you don't know how to do Desmos, I'm going to show it to you real quick right now.
It's already bad, minus 15.
Oh.